Today we'll be doing a 1989 APC physics question. This question starts off with a 0.1 kilogram block, which is released from point A, as shown in the diagram. This block then goes down the inclined ramp, going a vertical distance of h. As it slides down, it completes a circular loop of radius 0.50 meters. After completing the loop, the block goes on yet another ramp of heightened to an elevation of 30 degrees. At point C, 0.50 meters above the ground, the ramp ends and the block flies off. So our givens are the mass of the block at 0.10 kilograms, the length at which it flies off the second ramp, 0.50 meters, and the radius of the loop, also 0.50 meters. Part A of this question wants us to determine this height over here. The first thing that we should turn to is the conservation of energy. So the grand formula for that is that the total work done is equal to the change in kinetic energy plus the change in potential energy plus the change in internal energy. This problem does not have internal energy because there is no friction, and they state that the air resistance is negligible. So ultimately we get this crossed out, and the change in kinetic energy equals the change in potential energy. With this, we can see that throughout its trip, the mass of the block will have constant energy. So the energy at point A equals the energy at point B, which equals the energy at point C, which will equal the energy at practically any other point. So for now, we'll focus on energy at A and C in order to get the height. The potential energy at A plus the kinetic energy at A will have to equal the potential energy at C plus the kinetic energy at C. Since the block starts from rest, there is no kinetic energy at A. So we can get rid of that, and we have mgh equals the potential energy at C, which we know is mg and the length of 0.50 meters plus 1/2 mv squared. All right. Another thing that I forgot to mention is that the velocity at point C is given to us, and it is 4.00 meters per second. So that is something we'll need for our problem. After plugging in the numbers, you'll see that we can cross out the n's. And we isolate the h, so we get h is equal to GL plus 1/2 v squared divided by g. And when we plug in, we get h equals 9.80 meters per second squared for gravity. The length at 0.50 meters plus 1/2 the velocity, 4.00 meters per second squared, all divided by 9.80 meters per second squared. If you do this out on a calculator, you will get h is equal to 1.32 meters. That is the end for part A, but stay tuned for parts B, C, D, and E.